Hey guys, back here with day 17. We're looking a little bit more at the chain rule today. And today we're going to look at what happens when we do the derivative of a function within a function within a function. So let's, I'm going to throw, just like yesterday, I'll throw the rule out there right away and then we'll look at some examples. So I'll make that a little bit easier for us. So again, here's what we have. I'm going to try tilting the computer a little bit, so hopefully the audio I don't kind of get drowned out here. So if you're asked to find the derivative of a function within a function within a function, that even looks crazy to write. But we have a function h of x within a function g of x within a function f of x. Well, to do that derivative, it's still the chain rule. And I think, okay, what's the outermost function here? Well, the outermost function is f, so I'm just going to do the derivative of the outside with respect to the inside. Same as usual, right? So I have f prime of the inner function, g of h of x. But the chain rule also says I need to tack on the derivative of the times the derivative of the inside. But when I go to do the derivative of the inside, I have another function within a function. I have another composition of two functions. So the derivative of the inner function here, g of h of x, it has its own chain rule. So it's going to be times, well, if I want to do the derivative of g of h of x, that's what we did in the video yesterday. That's going to be g prime of h of x times h of x. Sorry, times h prime of x. So I do the derivative of the outside with respect to the inside times the derivative of the inside. Well, this inner function here, g of h of x, its derivative is g prime of h of x times h prime of x. So it's like we just kind of keep doing the chain rule until we're out of functions to do the chain rule. Function within a function within a function. It's kind of like a dream within a dream within a dream. So you can call it chainception, like the movie Inception, or I like to call it, name it after a famous rapper. I like to call it 2 chains. So I'm going to call it 2 chains problem. Here's an example of what I mean by that. So let's say we have a function f of x, and f of x equals cosine cubed of 4x squared. Find f prime of x. Okay. So here we see a composition of 3 different functions. One thing that can help here is to rewrite f of x so we can really see our innermost and our outermost and our in-between. I'm just going to take a step to rewrite f of x. Notice I'm still labeling it out. I'm still labeling this thing f of x, right? I'm not doing a derivative right now. All I'm doing is rewriting this thing. And I'm going to write this cubed on the very outside. So I'm going to write this as parentheses cosine of 4x squared. Okay, when I look at this function then, this is like my h of x up here. This is like my g of x up here. And this is like my f of x up here. Okay, so my outermost function here is x cubed. My innermost function is 4x squared. And the one in between is cosine of x. So when I go to do f prime of x, I do the derivative of the outside with respect to the inside. So I've got 3 is going to come up front. And I'm going to keep the inside alone, and I'm not going to mess with it. And I have 3 cosine of 4x squared whole quantity squared. Okay? That's like f prime of g of h of x. But now I need to multiply by g prime of h of x. Right? I'm doing the derivative of this cosine of 4x squared. Well, if I just gave you this problem, cosine of 4x squared, you could do that right now. Right? That derivative would be, I'm going to multiply by negative sine of 4x squared. So this is like my g prime of h of x. The derivative of cosine is negative sine, but it's with respect to that inside of 4x squared. And the very last thing I'm going to multiply in is the derivative of h prime here, which would be 8x. Okay. And we have this big kind of messy equation here for f prime of x. What I like to do now is multiply all the coefficients together and just rewrite this thing a little bit more cleaned up. So I've got coefficients, I've got the 8, the negative 1, and the 3. I'm also going to take that polynomial x and throw it out front. So 8x times negative 1 times 3 is a grand total of negative 24x. Okay. I'm going to write this in the notation with the co-squared in here. So I'm going to call it negative 24x cosine squared of 4x squared sine of 4x squared. These things are all multiplied together, so there shouldn't be any pluses or minuses in there. Also, sometimes people take this minus and throw it out front, like I did here, and then rewrite the minus again down there. You can't do that. Once you throw it out front, just remember that you threw it out front and you don't need to include it in your rewrite. And there we have the correct solution of negative 24x cosine squared of 4x squared sine of 4x squared. Okay. Let's try one more. I'll make up one more here. Okay, so here's my function. G of x is e to the power of tangent of 3x. So once again, 3x is my innermost function, followed by tangent, followed by e. E being my outermost function here. So again, in my f of g of h of x, f of x would be e to the x. G of x would be tangent of x, and h of x would be 3x. And f of g of h of x would be e to the tangent of 3x. Okay, doing the derivative now. I'm going to do the derivative of the outermost function, which e is its own derivative, so it's going to be e with respect to the inside. So this is going to start off e to the tangent of 3x times the derivative of tangent 3x. Well, the derivative of tangent 3x is its own chain rule. So with an outer and an inner function. So I do the derivative of the outside, which is secant squared, with respect to the inside 3x, times the derivative of the inside 3. Clearing this thing up, I'd write this as 3 secant squared 3x e to the tangent of 3x. And there we have it. We got it. Okay. All right. One more thing. sometimes there's chain rules and we may not recognize it as a chain rule because we're mixing function notation with non-function notation. I showed you a couple of, period 8, you saw a couple examples of that. Let me just show you one for everybody. Let's say you're given a function h of x, and that function is defined as g of 2x squared. And then I want you to find h prime of x. Okay? Well, again, don't be confused with this g, right? That's just saying it's a function g. We don't know what g is. Maybe we have a table for g. Maybe we have an equation for g. Maybe we have a graph for g. Whatever it is, right now we don't really know what it is. Okay? But once again, this is a classic chain rule problem because I have a function 2x squared embedded within an inner function 2x squared embedded within an outer function g. So if I wanted to find h prime of x, I can still do the derivative of the outside with respect to the inside. So my derivative here would be g prime of 2x squared. Okay, that's the derivative of the outside with respect to the inside. And then I would just need to multiply by the derivative of the inner function. Well, the inner function, 2x squared, that derivative would be 4x. So I know h prime of x could be written as 4x g prime of 2x squared. Okay. Similarly, I might give you another function, j of x, and I'm going to define j of x as f to the 4th power of x. All right, again, if we see this notation here, we may not have seen this notation very much in pre-calc or algebra 2, but we've seen it with trig functions, right? When we write that to the 4th superscript in between the f and the of x there, this can be rewritten. It should be known that this means f of x to the 4th power. Well, when we look at it like that, it's pretty easy to see that f of x is our inner function and x to the 4th is our outer function. So if I wanted to find j prime of x, right, I can do the derivative of the outside with respect to the inside. And I'll get 4 times the quantity f of x cubed. And now all that's left is to multiply by the derivative of this inner function. Again, I don't really know what f is right now, but I know the derivative of f is written as f prime of x. Right? So I get a final answer, just to write it in the notation of the problem given. I can write it in a nice, neat notation of 4f cubed x times f prime x. Right? Those are chain rule problems, but they're mixing function notation with regular defined functions. That's it for today. We'll practice some more of this stuff tomorrow, and I'll have some more chain rule stuff for you for Friday as well. Talk to you guys later. 2 chains. Bye.